Imagine waking up 100,000 years ago and deciding that your first task is not finding breakfast, checking the fire, or avoiding the large cat that has been watching your camp. It is makeup. You crush a red stone into powder, mix it with fat, water, or something equally prehistoric, and smear it across your skin. No mirror, no bathroom, no influencer explaining the correct shade for late Pleistocene autumn. The obvious explanation is decoration. Early humans painted themselves red because they wanted to look impressive. But that answer is far too tidy. Red ochre may have protected exposed skin, helped process animal hides, strengthened adhesives, marked group membership, transformed rituals, or made one person instantly recognizable to everyone around them. And the most frustrating part is that skin disappears. Archaeologists can recover the pigment, grinding stones, and even ancient mixing containers, but not the painted body itself. So why did prehistoric humans begin turning red earth into a second skin? The answer involves microscopic scratches, a 100,000-year-old pigment workshop, and a color that may have become one of humanity's earliest social signals. Let's grind the evidence down to powder. The short answer is that red ochre was useful, visible, and easy to transform. It could coat a surface, survive exposure, and turn an ordinary body into something other people noticed immediately. The longer answer begins with an inconvenient fact. We do not know when body painting started. Ochre is not one single substance. It is a broad family of iron-rich earth materials that can produce yellow, brown, orange, and red pigments. The deepest reds usually come from hematite. Break the material apart, grind it into powder, add water, fat, marrow, or another binder, and you have something that can cling to skin, hide, wood, stone, or fibers. That versatility is exactly why the archaeological record becomes difficult. Hominins were collecting and using ochre hundreds of thousands of years ago. Across Africa, the evidence becomes more frequent after roughly 330,000 years ago. And by around 160,000 years ago, ochre appears at enough sites to look less like an occasional experiment and more like a repeated cultural practice. But repeated ochre use is not the same thing as repeated body painting. The earliest pieces may have been used for abrasion, hide processing, adhesives, coloring objects, coating bodies, or several jobs we have not reconstructed yet. Archaeologists can identify the mineral and sometimes the way it was scraped or ground. They cannot simply turn over a red stone and read, "Applied to forehead before mammoth hunt." So before red ochre became a social signal, it had to solve a more basic problem. What could a layer of red earth actually do for a naked human body? Start with the body itself. Humans are unusual primates. We lost most of our thick body hair, became excellent at sweating, and turned a large area of skin into direct contact with sunlight, wind, dust, insects, and every thorn apparently designed to attack an ankle. This helped us release heat while walking and running long distances. It also left us with a very large, sweaty surface and no instruction manual. Red ochre could change that surface. Once ground into fine powder, certain ochres can be spread directly onto skin or mixed with fat to create a thicker, longer-lasting coating. The layer does not need to behave like modern sunscreen to be useful. It only needs to reduce some exposure, stay on the body, and be simple enough to replace when sweat, rain, or a badly planned river crossing removes it. Modern experiments have tested this idea. Researchers applied different ochre mixtures to human skin and found that some produced measurable protection against ultraviolet radiation. Depending on the mineral composition, several mixtures reached sun protection factor values roughly between 4 and 10. That is not a prehistoric bottle of SPF 50, but it is not nothing. A mineral coating may also have helped keep a greasy binder against the skin and created a physical layer between the body and parts of the environment. Claims about repelling insects are harder to connect directly to ancient evidence, so the sunlight hypothesis remains one of the clearer functions researchers can test. Still, an experiment tells us what ochre can do, not why a particular person used it 100,000 years ago. And this is where the neat sunscreen story begins to crack. Because the same red powder works on far more than skin. There are two very convenient stories about red ochre. The first says prehistoric humans discovered makeup. They saw a beautiful red stone, rubbed it on their faces, and symbolism began immediately. The second says the opposite. Ochre was merely a tool-useful dirt with no more cultural meaning than a sharpening stone. Both stories are probably too neat. The same piece of ochre could perform several jobs. It could be ground into pigment, rubbed across animal hide, mixed into adhesive, applied to skin, or used to color an object. At some Middle Stone Age sites, red ochre survives on the backed edges of stone tools where handles or shafts were once attached. In those cases, the red material was part of engineering, not eyeliner. Experiments also show that iron-rich ochre can help process hides by absorbing fats, abrading tissue, and slowing decay. Some archaeological pieces carry combinations of grinding and rubbing marks that fit this possibility. But fit is the important word. Rubbing ochre across hide can leave marks similar to rubbing it across skin. Grinding it for glue can resemble grinding it for paint. A flattened red stone does not come with a tiny product label explaining whether it belonged in the workshop, the wardrobe, or on someone's forehead. Prehistoric ochre was less like lipstick and more like an entire hardware, skincare, and art aisle compressed into one dusty rock. And practical use does not cancel symbolic use. A substance can protect a hide while coloring it. It can strengthen an adhesive while making a tool visibly distinctive. It can shield skin and still tell everyone who belongs to the group. So the question is no longer simply, was ochre functional or symbolic? The real question is whether microscopic damage can reveal which surface that red stone once touched. Fortunately, rocks preserve scratches better than humans preserve skin. Now, here's the part nobody expected. A lump of red earth can record a history of movement. Under magnification, an ochre fragment stops looking like a simple rock. One surface may have been ground flat against stone. Another may carry parallel grooves from scraping. Its edges may be rounded, its ridges polished, and fine red powder may still be trapped inside microscopic scratches. Archaeologists compare those traces with experiments. They grind fresh ochre on stone, score it with sharp tools, scrape off powder, or rub it across hard and soft surfaces. Then they examine the damage left behind. Grinding tends to create flattened facets crossed by striations. Scraping can leave narrower grooves. Using a piece like a crayon may round its tip and polish the areas held between the fingers. This is useful. It is not magic. Different actions can produce overlapping traces, especially when the final surfaces are soft. Skin, hide, fiber, and wood do not sign their names after contact. Usewear can show that a piece was deliberately processed or rubbed. It may narrow the possible surfaces. It rarely announces, with complete confidence, left cheek. Then there are objects that accidentally carry the story farther. At Blombos Cave, archaeologists recovered small, perforated sea snail shells from levels dating to roughly 75,000 years ago. Wear around the openings and surfaces indicates that the shells had been strung and worn as beads. On 4 of them, researchers identified microscopic traces of red ochre inside the shells and across their outer surfaces. How did the pigment get there? Perhaps an ochre-covered tool touched the shells while they were being perforated. Perhaps the beads were deliberately colored. Perhaps they repeatedly rubbed against a red-painted thread, garment, or body. We cannot choose among those possibilities with certainty, but notice what has happened. The evidence has moved from a mineral lying on the ground to an ornament that once moved with a person. Picture a necklace sliding against a painted neck. The skin decays. The cord disappears. The person, their name, and the meaning of the color are lost. But a few red grains remain protected inside a shell. Skin is a terrible filing cabinet. Tiny beads are occasionally better. And if prehistoric humans were already preparing pigment carefully enough to place it on bodies, clothing, or ornaments, the next clue should not be another loose red stone. It should be a recipe. Then, at Blombos Cave on the southern coast of South Africa, the red dust stops being an isolated clue and becomes a workbench. About 100,000 years ago, someone gathered ochre, selected stone tools, crushed mineral-rich material, broke animal bone into small fragments, and prepared a liquid mixture. The ingredients included hematite-rich powder, charcoal, crushed bone, stone chips, quartz grains, and some form of liquid. Then they placed the compound inside abalone shells, not one shell. 2. One toolkit included a large stone resting inside the shell, stained red underneath, as if the work had been interrupted and the tools simply left where they were. Nearby were grindstones and hammerstones used to reduce the ingredients. The mixture itself had been stirred into a liquefied, ochre-rich compound and stored in the shells for later use. This was not someone casually rubbing a colorful pebble on a wall. It required finding materials from different sources, understanding which parts needed crushing, combining them in a workable order, and using a container that would not immediately absorb the mixture. There was no printed recipe, no measuring spoon, and absolutely no customer support number. But there was a sequence. That sequence matters because recipes exist in the mind before they exist in the bowl. The Blombos toolkits show planning, material knowledge, and the ability to preserve a compound for future use. What they do not show is where the compound went next. It may have coated skin, it may have colored hide, wood, stone, ornaments, or another surface. The researchers who described the discovery explicitly left the final application unresolved. Decoration and skin protection are possibilities, not verdicts. The evidence is powerful precisely because it is incomplete. 100,000 years ago, people were not merely finding red earth. They were engineering it into something portable, spreadable, and reusable. And once a community has a recipe like that, the question changes again. Why invest this much effort in a color unless the result mattered after the mixing was finished? So, what was red ochre probably used for first? The honest answer is that first may be the wrong shape of question. Ochre was not a single-purpose invention. Different communities could discover different uses at different times, and one person could use the same powder for several jobs in the same week. The first strong possibility is surface protection. Mixed with fat or liquid, ochre could coat exposed skin. It could reduce some ultraviolet exposure, hold greasy material against the body, or create a replaceable barrier between skin and the environment. Rubbed into animal hide, mineral powder could also absorb grease, help remove tissue, and color the finished material. The second possibility is technology. Ochre appears in some prehistoric adhesive mixtures used to attach stone points or cutting edges to handles. Experiments suggest that adding the right amount of ochre can change how a compound spreads, grips, and responds to stress. In that setting, red powder was not decoration. It was engineering. And then there is visible transformation. Ochre produces a strong, durable color on skin, hide, fiber, wood, and ornaments. Once people notice that, practical use could become social almost immediately. A protective coating could develop into a pattern. A treated hide could become a recognizable garment. A useful mixture could also make a tool or body look different from everyone else's. We often separate function and symbolism because modern stores put glue, sunscreen, cosmetics, and paint in different aisles. Prehistoric humans did not have aisles. For them, one mineral could be skincare, workshop ingredient, and group uniform before lunch. That does not mean body painting began accidentally. It means there may never have been a clean moment when useful red earth suddenly became meaningful red pigment. The meaning could grow from repeated use. Much later, at Sibudu in South Africa, people produced an even stranger mixture. Residue dating to about 49,000 years ago combined powdered ochre with casein from the milk of a wild bovid. Chemical analysis indicates that it was a paint medium rather than hafting glue or residue from hide processing. It could have been spread across stone, another surface, or human skin. Once again, the recipe survives. The canvas does not. And if similar discoveries happened in different places and among different kinds of humans, red ochre was not one community's invention. It was a possibility waiting beneath many people's feet. The red trail does not end with Homo sapiens in South Africa. At Maastricht Belvedere in the Netherlands, archaeologists found small concentrations of red material among stone tools and animal remains left by early Neanderthals. Chemical analysis identified the material as hematite, the iron oxide that gives many ochres their red color. The site dates to at least 200,000 to 250,000 years ago. There was no natural source of hematite in the excavated sediments. Someone had brought it into the excavated area from elsewhere and reduced part of it to powder. That required selection, transport, and a reason to keep a red mineral that could not hunt, cut meat, or complain usefully about the weather. What was it for? We do not know. It may have served a practical purpose, colored a material, or been applied to a body. The evidence demonstrates Neanderthal ochre use. It does not give us a Neanderthal face with two tasteful red stripes. Across Africa, meanwhile, ochre appears in southern, eastern, and northern regions over immense stretches of time. The pattern is gradual. Scattered early experiments, increasing use after roughly 330,000 years ago, and a more habitual practice from around 160,000 years ago. That matters because it destroys the idea of one genius inventor suddenly announcing body paint to the world. Different hominin groups could notice the same useful properties independently. Red earth was widespread. Human curiosity was apparently even more widespread. But minerals are not culture by themselves. Culture begins when people learn how to select, prepare, apply, and interpret them together. Once a color is repeated across generations, it can become more than a coating. It can become something other people know how to read. Now, the body itself becomes part of the message. A mark on a cave wall stays where it was made. A painted person carries the color into camp, across a hunting ground, and towards strangers. That makes body pigment unusually powerful. It is portable, visible, and temporary. You can add it, remove it, change the pattern, give several people the same mark. Once a community agrees that a color or design means something, the coating becomes more than decoration. It can identify who belongs together, who has reached a new stage of life, who is performing a particular role, or who is entering an event that ordinary appearance is not enough to express. Could red ochre have marked hunters, healers, mourners, adults, leaders, or marriage partners? Possibly. But archaeology cannot recover the dictionary. We should not assume that every red face meant blood, fertility, danger, or sacred power. Those meanings vary across cultures, and the people who used the earliest pigments left no captions. What the evidence supports more safely is the existence of visible modification. People invested effort in selecting colors, preparing compounds, and combining pigment with objects worn on the body. That is enough to create social language. The repeated mark matters because other people recognize it. A child sees who applies it. An adult learns when it should be worn. The method survives because someone demonstrates the recipe and someone else remembers. In modern terms, body paint can work like a uniform, profile picture, and status update without requiring electricity, fabric, or a password nobody remembers. But every signal contains a boundary. The same red pattern that says, "These are my people," can also say, "You are not one of us." And that is where a useful mineral begins to reveal its less comfortable power. Every social signal has a shadow. A painted body can say, "I belong here." The same mark can also identify the person who does not. If ochre patterns carried information about age, role, alliance, or participation, then access to those patterns may not have been equal. Some people may have known the recipe. Some may have controlled when it was applied. Others may have been permitted to wear a mark only after completing a task, entering a new life stage, or being accepted by the group. That reconstruction is plausible, not proven. Archaeology preserves pigment better than permission. Red also attracts interpretation because it resembles fresh blood. That resemblance may have made the color emotionally powerful in some communities, connecting it with injury, vitality, hunting, birth, or death, but there was no universal prehistoric color code. Red could carry different meanings in different places, or no symbolic meaning at all in a particular use. The material itself could also acquire value. High-quality ochre was sometimes selected, transported, and processed with considerable effort. Knowing where to find it, how to prepare it, and how to produce the expected shade could turn technical knowledge into social influence. Humans had managed to invent membership rules out of dirt. That is not necessarily sinister. Shared markings can strengthen trust and cooperation. But every visible symbol makes classification easier, and classification can support hierarchy, exclusion, or control as easily as solidarity. So body painting was not merely a colorful step toward art. It may also have helped humans decide who was recognized, who was transformed, and who remained outside the circle. Which leaves us with the hardest question of all. How much of this can the evidence actually support? So, what is the real answer? We know that prehistoric humans and other hominins deliberately collected red ochre, sometimes carried it away from its source, ground it into powder, rubbed it across surfaces, and eventually mixed it into prepared compounds. By roughly 160,000 years ago, ochre use had become frequent enough across much of Africa to look like a sustained cultural practice rather than a series of isolated accidents. We also know that some ochre was used technologically. It helped prepare materials, entered adhesive mixtures, and colored objects that moved with the body. What we strongly suspect is that some of it was also applied directly to skin. The wear on ochre pieces, pigment on personal ornaments, experiments with mineral coatings, and carefully prepared mixtures all make body painting plausible. None of them preserves the first painted face. What remains debated is how often ochre was used on bodies, whether protection or display came first, and when repeated coloring acquired shared social meaning. And what we cannot know is the exact thought behind the first red handprint dragged across human skin. So, prehistoric humans probably began painting themselves because ochre could do two unusually valuable things at once: alter the body physically and alter how that body was seen. There was probably no single invention day. No one announced that the Stone Age had entered its red phase. Instead, useful earth became repeated practice. Repeated practice became tradition. And tradition made the human body readable before anyone spoke. Now return to that morning 100,000 years ago. The person beside the fire crushes a red stone, mixes the powder, and spreads it across the skin. We cannot know whether the goal is protection, beauty, belonging, ceremony, or several of those at once. But the behavior should not feel strange. You probably altered the surface of your body before leaving home today. Perhaps you applied sunscreen, makeup, moisturizer, perfume, hair dye, or a symbol printed across your clothing. Humans still use appearance to manage the environment and manage what other people see. We paint faces for sport, we mark bodies with tattoos, we wear colors for weddings, funerals, professions, protests, celebrations, and groups we have decided matter enough to display in public. The materials changed, the logic did not. A layer on the body can protect you while communicating something about you. It can be practical and emotional, private and public, temporary and unforgettable. So perhaps that prehistoric person was not choosing between survival and self-expression. The distinction may not have existed yet. The same red mixture could protect the skin, complete a ritual, identify a companion, and make the person in the reflection of a dark pool look suddenly different. No mirror required. The body vanished. The color remained. And somewhere between protection and performance, humans discovered that skin could speak before the mouth ever opened.